Computer Science A, Unit 6 Arrays, Lesson 3, Algorithms on Arrays. In this lesson, we're going to analyze examples of common algorithms which are used on arrays, and you'll be able to recognize, debug, and create these common algorithms yourself. First, we're going to look at adding an element to an array at a specific index. This version of adding an element is much like adding an element to the end of the array, but the new element can be put anywhere in the existing array instead. So we're going to write a method called add@index that accepts an array of strings that list the letters, the letters excluding C, the letter you want to add, and the index you want the element to be added at. It adds the letter grade C in the array at the appropriate index and returns the new array. So if we take a look at this, down here, what we have is string of letters A, B, D, E. And notice we're missing C. String new letters, add at index of letters, index to the letter C. So notice we want A, B, I want C to be where D is, but I don't want to necessarily lose D and E. So here's my string of letters, A, B, C, D, E, or A, B, D, E, and the indices. What I need to do is call add@index, and I'm going to pass letters to it, which means add@index is going to have something, an array, a parameter, okay, that's going to wind up pointing to letters. So let's first write down our pseudocode or our plan. So the first thing we need to do is create a new array with one additional index. Now notice public static string add@index, because I've got to return my new string. It's going to accept the string letters in ARR. So there's where we've got our pass by reference. Then I need the index, which happens to be 2, and the string word, okay, which is letters here. So I need to create a new array index with one additional index. That's going to be string new array. Here's my new array right here, and it's going to be a new string, and it's array.length plus 1. Remember, array was passed in, so array is 1, 2, 3, 4 long, so my new string will be 5 long. The second step, I'm going to copy over everything up to the index you are adding at. So I want to copy A, B, and that's it, because 0 and 1 are going to be the same. So I'm going to copy over, see if I can write here, boop, pen. I want to copy A, and then I want to copy B. So for I is set to 0, I is less than index. And index is what was passed in, which was 2. So this is going to be do 0 and 1. New array sub I is going to be set to whatever was in array sub I. So A goes to A, whatever's in 1 goes to 1, and then I drop out of this loop. What next? I want to add item at that index. So now I'm going to make my new array, okay, new array is going to, new array sub 2 is now going to receive my character or letter C. And how do we write that? Like this. New array index, because that was what was passed in, is equal to word, which in this case is C. Okay. Then I need to finish copying. Now I've got the stuff before, I need to copy everything after. So I need to go to index plus 1 all the way to the end and copy. So I is set to index plus 1, I less than new array dot length, I plus plus, new array I, so 3 is going to, get whatever was in 2's location. So it's going to get the D. And then I loop through again, and what goes in location 4 is what was in location 3, which is an E. And now I'm at the end of my loop, and I drop out, and I return new array. In returning new array, okay, here's my new array, new array is getting returned to new letters, so new letters will point to the same location. Take a moment and look through the description, the pseudocode, the design, and the actual code. Next, what if we want to remove an element from an array? Removing an element follows the same basic algorithm for adding one, except that the new array is now smaller rather than larger. The process can best be described as creating a new array that has room for one less element than the original array. And we're going to do, and sorry, just trying to fix typos as I see them. Then the original array, then copying the contents of the original array into the new array, skipping over the element to be removed along the way. We're going to write a method called remove@index that gets the array and the index of the element to be removed as method parameters. It will remove the item at the index and decrease the array size by 1, and then it will return the new array. All right. So here, let's take a look at this and walk through it, okay? So int quizzes is 80, 92, 35, 77, 99. Int new quizzes, remove at index 2 quizzes. So here's 0, 1, 2. Essentially, we're dropping our lowest quiz. So we first start out and we declare quizzes. It points to a location in memory, and then we load that location up with our quizzes. Then we're going to call new quizzes, or we're going to instantiate new quizzes. So new quizzes, I've got it out here, and it's going to point to something, but what is it going to point to? It's going to evaluate this function that says remove at index 2 quizzes. So I'm going to pass in 2, and I'm going to pass in quizzes. So when I get over here, I've got to take as parameters an int, which is my index. So remember now, we're going to pass in a 2, and then int array, this was quizzes. And quizzes, that means all that's going to tell us here, if I can write that, is that these two are going to point to the same thing. Remember, it's a pass by reference. So if I change array, ARR, that means I'm changing quizzes. But ARR is looking at exactly the same thing that quizzes is. Now, my pseudocode, what has to happen? Well, first, I create a new array that has the size equal to the size of the original minus 1. So that would be dot length minus 1. So I want one less than array. Here's my new array, and it's array dot length minus 1. Now, what next? I want to use a loop to assign elements from the original to the new array up to the index we need to be removed. So here, I'm going to assign 80 to 0, then I'm going to put the 92 in here, and then I'm going to stop. So I'm going to need a for loop that's going to start at 0 and go up to but not include the index. And then I'm just going to put into new array whatever was in array at the exact same location. Now, all that happens, I'm not putting anything else in here. I'm skipping this guy. I'm skipping 35. So now I have another loop, okay, that just jumps past that. So now I'm going to start at I plus 1 for array, and I'm going to put it into I, but I'm going to have the new array is going to start at index 2, but it's going to take from 3. 3 is going to take from 4. So here's my new loop. I is set to index. I is less than new array dot length. I plus plus. I'm going to put into new array sub I. Make sure I'm new array sub I. So that's a 2. Whatever was in 3, and then 3 gets whatever was in 4. Then it's done. And now I'm going to return new array. So here's where new array is. It's going to return it so that new quizzes gets it and is now pointing to it. Again, pause the video and make sure that you understand how this code works. Creating an array by combining two arrays. This is just make a new array that is the same length as the two combined arrays, and then moving everything from the first one and then into the second one. So here, the pseudocode: create a new array with size equal to the combined length of the two arrays. Use a loop to assign elements from the first array to the new array using the same indexes until the end of the first loop. Use a second loop to assign elements from the second array to the new array, offsetting the index in the new array by the length of the first array, and then return the new array. On the next slide is a summary of this information about the method to be written. So here we have a return type, okay? We're going to return a string. We're going to call this add. Could also call it concatenate. The first array, string array 1. The second array, string array 2. The combined array is just a string. It's going to be returned. So notice the type is string. The name is add. String array 1, string array 2. My new one, my new array is new. It's going to be an array of integers. And how long is it? It's the length of the first one plus the length of the second one. And then this first loop is going to copy everything from the first array into the new array, and it's in exactly the same locations. The second loop, okay, starts at I, is 0, and goes to the length of the second array that was passed in. But now in the new array, I'm going to make I plus array1.length, because remember, I want to start after I finish copying, and the last element was at array1.length minus 1. So now this is going to start at array.length and continue until the end of the new array or the end of the array 2. And it just keeps copying in. Then I return the new array. Pause the video if you need to. Look at this. Make sure you understand what each piece of code is doing. Okay, swapping values in an array. Okay, remember, to swap two elements of the array, a simple algorithm can be followed. Store the value of the first element in a temporary variable, assign the value of the second element to the first, assign the value of the temporary element to the second element. Remember that if I have two boxes, or two buckets, we're just going to make two buckets, how's that? I have two buckets, okay? And what I have in these two buckets, let's see here, let's say I have a star in this bucket, and I have a heart in this bucket. And all I want to do is swap them. Well, each one of these buckets can only hold one picture. So I can't put this over here. I can't also let this float just off in space because it'll float right away. So what I have to do is I have to come along and I have to create a temporary space, okay? Temporary. So out here, whoops, did not mean to do that one. Boop. We're going to delete that. We're going to create a temporary holding bucket. So here's my temporary holding bucket. Now I can ask this temporary holding bucket to hold my star while I move the heart over to the first place. Then I ask the temporary holding to give me back the star. This is how we switch things around or swap values in an array or any two variables in a computer. So down here, consider the following data set of string array called animals: dog, goat, cat, T-Rex, duck. Write the code to swap goat and duck. So now remember that if we're looking at our indices, we have 0 is here, goat is at index 1, cat is at index 2, T-Rex is at index 3, and duck is at index 4. So what I want to do is I want to swap goat and duck. So I want to swap the values that are at index 1 and index 4. And they're both of type string. So I need a temporary string variable. And I'm going to set it equal to, I'm going to set it equal to the first one. So here, see if I can do this guy, temp, is going to get the value of goat. Boom. Then animals sub 1 is going to get duck. So I'm going to take duck and I'm going to move duck down here. Okay. And boop. Nope. Sorry. So now duck gets moved to goat. And then from temp, who now has goat, I'm going to put that back. So now temp is going to come back over here and put goat here. This is the code that allows us to swap. A common mistake is to say that animals sub 1 is set to animals sub 4. Well, remember that if I take whatever's in 1 and I set it to what 4 is, I essentially delete that. This gets put in here and this gets thrown away to garbage. So then when I put into 4 what is in 1, I'm just going to make a copy of this guy. And so now both of these will hold a star. This is a common mistake. You have to have a temporary holding place. It's got to kind of think of, I got 2 hands, I need a 3rd hand so I can swap. Shifting elements right or left. The algorithm below shifts every element 1 place to the left. It is very similar to the one we use to delete elements, but we place the first element at the end instead. So remember, we have to have a temporary holding place for what's being moved so I don't lose it. So we're going to move 15 into our temporary spot. Then we're going to take each one of these elements and we're going to move it down. So I'm going to put in location 0 what was in location 1. So I get 16. Then whatever's in location 2 goes to 1, which is 17, 18. And notice, at the very end, I have 19, 19. Because what I've done is I've taken all of these guys and I have put them right here. Now I have 19. Now what happens is after I've shifted everything down 1, I can take and whatever was in temp, which was 15, and I'm going to put it at the end. So this guy, whoops, gets replaced. So 19 gets the 15, and I have essentially taken the first element and put it at the end. Now look carefully at the bounds on the loop. We don't include the last element index of the array in the loop, as this is set outside of the loop. Okay, I don't change 19 because I can't move something from down here, and I don't know that I need it to go to the beginning, and even then the beginning's already been changed. Shifting every element to the right is done similarly and is like our insertion algorithm in that we traverse backwards rather than forwards through the array. So I've put in some comments in blue here. The first line saves the value of the last element in temp. Then we've got our loop, which starts at the end of the list and replaces element with the value of the previous element and leaves the first element alone. So I'm going to replace the 70 with the 60, the 60 with the 50, the 40, the 50 with the 40, and the 40 with the 30. And then the first element is left alone. Outside of the loop, I replace the first element with whatever value was in temp, which happens to be the last element. So I replace this 30 with the 70. Okay. Again, all of these, they're not hard, but if you need to, pause the video and check them out. Reversing elements. This algorithm is a little different to the others and requires some careful thinking about bounds and indices. Okay, notice here, I'm going to start at the beginning, and I'm going to go all the way through the list, half of the list. Yeah, length divided by 2. And this is integer division because our indices or indexes are integers. And I'm going up by 1. So J gets the list.length minus I minus 1. This is the index of the element in the end half. So I now have temp gets list sub I, list sub I gets list sub J gets temp. So if I look right here, what this is doing is I've got 0, 1, 2, 3. It's going to wind up swapping 13 and 43. I've got sub 0 and I've got 3. I swap these. Then I move up 1 and I'm going to swap these 2 in the middle. And then I'm done. Okay? Because I have 4. 4 divided by 2 is 2. Questions there? If you've got them, ask. But also stop and just take a look at over here the example that's worked through and step it through. You can make a list of I's and J's. Figure out what you're doing. Remember, this divides. We're only going to go forward through half the list because once I've swapped the first half with the second half, if I kept going, I would start reversing things. I would be out of bounds. Sorry, out of bounds. And that concludes lesson 3.